All right, so this is the answer key of third quiz, which is about chapter 1, section 3. So the first question, it tends to maintain the ball's motion in a straight line path. Not only ball's motion, if an object is net force acting on an object is equal to 0, object follows a straight line path. So this is known as the law of inertia. That's why we say that inertia of the path tends to maintain ball's motion in a straight line path. Answer is A. An inline skater skates on a circular track of 120 meters in diameter. So diameter is 120 meters. So we should, of course, first find what radius is. Diameter divided by 2 is the radius. So radius of this circular path is 60 meters. And then tangential speed, so this is tangential speed Vt. If the skater's mass m is 68.2 kilogram, what is the magnitude of the centripetal force on the skater? Calculate the centripetal force because tangential speed is given. So m Vt squared over r is the equation for calculating the centripetal force. 68.5 multiplied by Vt squared, which is 9.2 squared, divided by radius is 60. So then let's find it. 9.2 squared multiplied by 68.5 divided by 60, it is equal to 96.6 Newton. So answer is 96.6 Newton. Choice is D. The amusement park ride spins riders around on swings attached by cables from above. This is the figure. The force that maintains circular motion of the swing is what? Gravitational force on the swing. Gravitational force is always downward, but the swing is moving in a horizontal circle. So then force must point the center of the circle. So gravitational force is not pointing the center of the circle. So this is not the correct answer. Magnetic force by the earth. So magnetic force acts on iron or something like this. So it's not causing this circular motion. It's that's why this is unlogical. The force applied by the cable. Yes, the cable's force is acting like this. So this is the tension, we say that. And this tension, one component of this tension points the center of the circle. So Ft is the force in the cable. So that its horizontal component, Ftx, is the centripetal force for causing the circular motion. Yes, the weight of the swing's fate and gravitational force are the same thing. Both are pointing downward. So that's why, because it's the horizontal component of the force applied by the cable, so that's why answer choice can be, yes, the force applied by the cable maintains circular motion, but it's horizontal component. Don't forget this. And question number 4 is Mars orbits the sun. Mass of Mars is given, mass of sun is given at a mean distance. Distance from sun to the Mars is this. What is the magnitude of that? The magnitude of the force that maintains circular motion of the Mars around the sun. So then, which means here is the sun. The Mars is moving a circular path. So the Mars and the sun, between them is of course radius of the circle. So that main distance will be radius of the circular path. So then we will find the force that maintains circular motion. In fact, we are going to calculate the gravitational force because gravitational force between the sun and the Mars is causing the Mars to follow circular path. So F is equal to G, mass of sun, mass of Mars divided by separation, square of the separation between them. G is 6.67 multiplied by 10 to the power of negative 11. Mass of sun is 1.99 times 10 to the power of 30 multiplied by mass of the Mars 6.42 times 10 to the power of 23 divided by distance 2.28 times 10 to the power of 11 but squared. So when we finish this calculation, let's do it now. I will multiply all these three first. 6.67 times 10 to the power of negative 11 times 1.99 times 10 to the power of 30 times 6.42 times 10 to the power of 23. Yes, this is the answer of this numerator. Then divided by brackets, because we should get the square root of this exponential number. 2.28 times 10 to the power of 11. But close the bracket, now squared. So this is the answer. 1.64 times 10 to the power of 1.64 times 10 to the power of 21 Newton. So it is the choice D. And an airplane is flying in a horizontal circle at a speed of 120 meters per second. Horizontal circle, and tangential speed is this. 120 is tangential speed. So the force exerted on the pilot's body, so then there is the force x on the pilot's body to balance circular path 6 times of his weight. So then centripetal force is the force which causes the pilot's body to move on circular path. So then centripetal force here must be 6 times of his weight. It is, remember, m times g is the weight. So then centripetal force must be 6 times mg. What is the minimum radius of the plane's path? Calculate r. R is the question. We will use the usual equation for centripetal force. Fc is equal to m v squared over r, and then we know that centripetal force is given in the question as 6 times of the weight, and 6 mg is the centripetal force. M v squared, v is 120 squared over radius of the path. So m and m will cancel. So then we know that g is 9.8, and we will calculate what r is. So then r and 6g exchange. R is equal to 120 squared divided by 6g. We know that 9.81. So then 120. So that let's do it. 120 squared divided by bracket 6 times g, 9.81, which is equal to 244, almost 245 if you round it. 245 Newton force acts on the pilot's body. And question number 6. The force that maintains circular motion of a bicyclist is gravitational force acting on the bicycle's body. Gravitational force is acting down, but the bicyclists are moving a horizontal path when it's turning. The gravitational force acts downward never becomes a centripetal force, because centripetal force must point the center of the circular path. So this is not correct. The force of friction between the tires of the bicycle and the ground. So this keeps the bicycle on the circular path, not bicyclist, not the man. This keeps the bicycle on the circular path, so not cyclist. That's why it's not correct. The force is between the bicyclist's body and the bicycle. This is the correct answer. There are two forces acting on the cyclist's body, which is one of them is the normal force between the bicycle seat and the body, and second one is the static friction force. This is the correct answer. The gravitational force acting on the moon by Earth is blah blah blah. The gravitational force acting on Earth by the moon. So Earth and moon, or any two objects, attracts one another with equal magnitude of the force. Reaction force must be equal in magnitude, greater than, smaller than, equal to. Yes, answer must be equal to. And the force that maintains circular motion of an object must be in the same direction too. Okay, we know that if an object is moving a circular path, so then there must be a force which points always to the center of the circle, which is known as the centripetal force. It must be in the same direction of the tangential acceleration. Tangential acceleration, as we said, is tangent to the circle, so it cannot be tangential velocity. It's also tangent to the circle. It's not, because centripetal force points to the center of the circle. Centripetal acceleration, yes, correct, because centripetal acceleration is also pointing the center of the circle. So answer is B. A car enters a horizontal curved road of radius of 50 meter. R is equal to 50 meters. The coefficient of static friction between the tires and the road is 0.2, yani mu s is equal to 0.2. What is the maximum speed which the car can safely negotiate? Calculate the maximum speed, tangential speed. We will calculate that. Remember, centripetal force is equal to mv tangential speed square over r. If centripetal force is enough to keep the car on the circular path, so then we can say that this car can safely make the turn. What is the centripetal force acting on a car which is on a horizontal road? It is of course static friction force, and we calculate static friction force by mu static friction multiplied by mg is equal to mvt squared over r. So m will simplify, so we will find vt cross product r times mu s times g. Mu s rg is equal to vt squared. Mu s is 0.2, r is 50 meter, g is 9.81, so which is equal to vt squared, and then after that get the square root. So let's calculate it. 0.2 0.2 multiplied by 50 multiplied by 9.81, which is equal to 98.1. Then the square root of this answer, which is equal to 9.9, almost 10. So Vt is equal to 10 meter per second. Choice is B. And two objects with two specific masses and then specific distance separates them. If the distance between them changes by a factor of blah blah blah, the force, gravitational force between them decreases by a factor of 9. Equation for gravitational force is this: G m1 m2 over r squared. We want gravitational force to decrease by 9, which means this must be 1 over 9. So then how much r must change to make this 9? Because 3, because if it is 3 but squared, if you get the square root of 3, it's going to be r. That's why r must increase by 3 or change by 3. So if the distance between them changes by a factor of 3, so then because distance increases, force will decrease. So but what? Square root of 3, which is 9. Force will decrease by a factor of 9. This is the choice A.